So today we're gonna do the homework 8. After I will record this and then upload it. Then after this, I will record a review session like the chi-square non-parametric regression and can't remember what else is, but ANOVA, yeah, all of them, and then I'll upload that. Before I start homework 8, I want to say this is gonna be the final week. You guys are all gonna be fine. Just relax. Everything's will be fine, okay? And yeah, okay, let's begin with homework 8. So we're gonna use regression and then parametric. So in last Monday's or Wednesday's class, we covered like one sample non-parametric. In this homework, we're kind of need to do 2 sample parametric. I know this is not really covered in class yet, so I'm showing all the command with the software, like it's here. This is all the command we're using. This is gonna be a lot easier for you. And I will have a lecture. I will post this online, of course, but I will teach a lecture because I teach this spring. I will just run through this. This is non-parametric stuff. I will run through everything here after this. Okay, so relax. It's gonna be all right. Okay, so for the first question, there is gonna be 2 data set. Let's look at this 2 data set. Okay, so this is the first one. Okay, so the first one looks like this. So this is the data, and then this is, it's a control group or the treatment group. This is the first data, and then let's see the second one. The second one looks like, oh, so there are 2 here. So you see the difference, right? Yeah. Okay, so we're just gonna choose different data set when we decide what are we gonna use. Then we choose the right data set to do the command. Okay. So first, there's control and there's a treatment group. And for the first question, we want to do a parametric test. So parametric is the one we're doing t-test, z-test, stuff like that. So here we're reading through the question, we're just going to do a t-test, 2 sample t-test, right? It is equal variance or not equal variance. So that's why we're just going to see which data we're going to use. No, this one. Yeah, we're gonna use this one. Okay. So for A, we're gonna do an SD test. So which variable are we gonna equal this to? So it's gonna be control equal to treatment group. Okay. And see here, the p-value is really large, so we're going to say we do not have sufficient evidence to say the variance is equal. So we're going to do a t-test, 2 sample t-tests with unequal variance. And it's unpaired, right? So t-test control equal tx should be unpaired, unequal. Okay, sorry. Unpaired, unequal. Yeah, I should add this like unequal. Here. So you see this? This is like 0.04, so we reject it. We're gonna say the p-value is not, we're gonna say the mean is not equal to each other. Okay. Okay, do the interpretation your result. So you're gonna say do you remember I posted the slide before? It's about what's your decision and what's your conclusion. Do that. Okay. So what non-parametric test could you be conducted? So you remember this my note I made, right? So for the 2 sample ones, these 2 are non-parametric and this is parametric. That's why I linked this 2 sample t-test here as a parametric one. So here, there are 2 non-parametric tests we can use. This is the median test. This is rank sum test. let's pause it just a little bit here. On Monday, Dr. Crafty taught us everything here. So this is a sign test, this is a sign rank test, this is the one sample t-test, which is parametric. So do you see the pattern here, right? There are one sample and two sample, there are more. And in each of these two branches, the first two are non-parametric and the third one is parametric. So weak, medium, strong, weak, medium, strong. So it's kind of like this, how strong the test is. And here are the conditions. So these two are the conditions where you can use in the answer. Okay. So yes, so there are what there are okay. So what kind of non-parametric test can you use? So it's gonna be median test and rank sum test. So what are their command? So median test, the command is this one. Do you see this? This is by group, right? So right now we need to change the data. We need to change back to this one. Just click it, it's okay. So now what we're gonna do is we're gonna do the B, right? B. And now we're gonna do the median test. Median SBP gonna be by group. So this is the P value. Yeah, so after the correction, you could see this is so weak, right? This one we rejected, even though it's kind of borderline rejected, we reject it. We will say, well, you are not the same. But here, because median test, they lose so much information, so less powerful, this test didn't even reject it. So let's try the rank sum test. It's gonna be rank sum BP by group. So as you can see, this p-value here is 0.0564. This one and this one, they're all kind of like just around 0.05, right? Let's just write all of them out. So 1, 2, 3. So the weakest one gave you the p-value. Let's do, even with the continuity correction, the weakest one p-value is this one, and the slightly stronger one, the p-value is this one, and the weakest one, oh no, the strongest one is this one. So you can see both of them are non-parametric. Their p-value is kind of slightly larger than 0.05, and then this is the other one, right? Yes, what I want to say is like goes this way, like goes this way, it's become stronger, so p-value is smaller. It's conditions on my map. Yeah, so the conditions is here. You can just copy this one. Which of the three tests do you think is most appropriate for these data? I would say this both of this two, like the parametric one, non-parametric are good, but I will definitely choose this one. Just give you a reason. There are other reasons on professor's slide like here, so just choose the right thing for you. Okay. Yeah. So okay. So let's put this here. So we're just gonna command it. Okay. Right. So now we're at question 3, right? Well, yeah, question 3 we solved it. Oh, actually we did finish number 1. Awesome. So now let's do question 2. Okay. So for A, what is A? So what is the, okay, let's open the data first, right? Okay, here is the data. Okay, let's see it. So here is the data. So okay, so this ID is the duration, stay, and age, sex, and everything. Okay, I'll return the message later. Yes. So what is first question? So what we want is a model, right? So there is an example like you can use first day temperature to predict the duration stay. Well, I'm just gonna use this one. I'm just gonna pretend I can predict how long you're gonna stay here by your temperature. Okay, so what is the model that I'm gonna testing, right? So I'm using x and y. So the model I'm gonna do is this one. So y equal to beta 0 plus beta 1 times x1 and plus error term, and y is the first day temperature and x1 is duration stay, right? And then we're gonna say, well, is this a least square regression probably for this data? Well, why not? So I'm just gonna build a scatter plot. So graph, can do not this, no, two-way graph. There is scatter plot, create, and then scatter plot, right? This basic. We're gonna use y is duration stay and x. See, that's as x is first day temperature. I'm gonna sort on x, and I will just let's click submit. Then you will see this. Well, I think it's alright. There should be like one line, like evenly distributed around the one line. That's like here, this outlier. But do you see this outlier here? This is something we can check, in the following questions. But let's just out of curiosity, let's try this at white blood cell. So do you notice when I click submit, I didn't click accept because when I click accept, this window just disappear, but I click submit, it just keep popping up what I want. So I would say this like, yeah, but none of them are actually good. But well, it's okay. Still using this one. Let's like click accept this time. You will see this window actually disappeared. Getting okay, and then it disappeared. Can't really correct it. But here, this is the scatter plot. So what do you think, right? Okay, for C, right. Okay, so here are the commands. So if you want to just make a slight change, you can just copy this command and do others. And then for C, determine the equation of the regression line for the model. So equation is gonna be, oh, did we regress it? Oh, so okay, so after we do this, let's fit the model, right? So how can you fit the model? It's gonna be regress. What is our y again? It's duration of stay plus temperature, right? And temperature, this is y, this is x, right? No, okay. ST, right? This one. So okay, awesome. So this is the model we got, and this is constant. So this is this number, and this is temperature. So what I did, how did this one get here? Do you remember we got this term? So let's copy it here. So y equal to this one. For the error term, because we don't explain it, it's gone. And this is constant, right? So constant is this beta 0, and this coefficient is beta 1. So this x1 is temperature, right? So this y is the duration of stay. So this is gonna be the model I got. Okay. Yes. And so this is the one I got. And so for D, what two interpretations can be made about two interpretations from the slope of the line describe? Okay. So I would say the interpretation would be this coefficient and temperature. This well, there are like kind of like cookie cutters, like kind of descriptions for this one, but I don't think the coefficient one is actually making sense, but you can still do that. For this one, you say every 1 degree temperature increase in temperature, the patient's gonna stay like it's gonna stay 1.659 days more in the hospital. And for this constant, I mean, it doesn't really make sense, like if the patient's temperature is 0, then the patient is gonna stay like less than 0 days. It's not really making sense. What you can do actually is in real life, you're gonna do the you're gonna center the temperature. So the temperature is gonna be a number around 0. Temperature nu is gonna be like a serious number around 0, then that will make sense. It's what I want me saying is you use temperature minus the mean of temperature. So that's actually how you that's how you center the data. But here this doesn't make sense. But let's just say if this number is like 10, I will just, if this number is 10, I will just say, for any patient whose like temperature is 0 degree, the expected stay is like 10 days. Does that make sense? Just let me know. If you are feeling confused, email me. And for E, we're using the regression equation to make a prediction, right? So what kind of prediction? You see, there's choose a variable, your independent variable. So I'm just going to choose one value for the temperature. Let's do this. I want to say display this temperature going to be, I'm just wondering what is like 40. Oh, so no, not 40. That's at 100. That's not too small. 100. Okay, so if a patient came in the first day, temperature is 100, he's probably gonna stay for 11 days. Okay. And for the next question is, what is R square? And then describe that square. Okay, so R square is here. That's a really, really small R. It's like point, like that's kind of only 4%. So let's explain this a little bit. What is R square? R square is how close the data to be fitted in the regression line. So it is a percentage of how the response variable variation is explained by a linear model. So let's say this. So duration of stay is actually related probably with age, gender, temperature, white blood cell, and all of this. And this temperature can only explain like the variation. This, if there's 100 part of variation, this temperature can only explain like 4%. Maybe this white blood cell can explain like 10%, then this can explain 10%. So but this one only explain like 3%, no, 4%, 3.91%. So yes, that is how you explain it, right? And for the last question, for no, not last question, for G, apply 3 methods where you can do this. So yes, so actually this is the answer for G. First, you can plot the residual, histogram it, or scatter plot it. It should look normal. But if it's not, you're just gonna say it's not normal, right? So how can I plot the residual? It's gonna be predicted y minus y. This is here. We're gonna do it together, so it's okay. And then, or you can access the outliers. And it's a bit of complicated. You need to identify each outlier and remove it to see if the model changes. I guess you could say you tried it and it does not change much, because when we are doing the scatter plot, there's like one outlier like really in the corner. That's probably gonna change it. And accept collinearity. This is do 2x2 scatter plot. But here, we don't really have that much. But let me show you how to do 2x2 scatter plot, okay? So it's gonna be in this graphics, and this scatter plot matrix variable is gonna be duration of stay, age, no, what? Let me think about it. Maybe not this one. Let me think about it. I think it should be this one. Sorry, I wasn't reading. Let's do duration of stay. I submit this to fields specified. Then age. Oh, okay. Then gender. Oh, okay. Temperature. So I'm just gonna take this. And white blood cell. Not this. Blood cell. This one. And this one. And this one. Okay, let's submit this one. it's gonna take a while, but let's skim back. When this is finished, we will look at it again. Okay, it's kind of slow right now, but what I'm saying is you can plot the two-way schedule plot with everything together, then you'll see what's the pattern around them between themselves. Okay, this is too much. Let's only include this much. So you can see there is a pattern. Like this one probably it's better for least square thing, age endurance day. There's a pattern here. This is a line and these two are symmetric and these two are symmetric. This is right, you understand me. So yeah, this is temperature and this is white blood cell. So this two probably can't do the least square. You can see something like here. So this is scatter plot. If we have this in class, you will understand. If not, just Google it or email me about this. Okay, and right now we're just gonna do the next question. How does this appear the errors? So how can we do the errors? So it's gonna be the residue. We're just gonna say gen. We're gonna predict it y equal to I didn't say d. Predict y equal to this times what? Times temperature, right? There's nothing saying, but here can you see this? Yes, we got it. So we're gonna generate residue. It's gonna be predicted y minus duration stay, and then we're gonna plot it. I'm just gonna do a two-way. Where's our two-way graph? Here, this one, right? Now, but here we're gonna change this one to the residue. So no, this doesn't really look like, yeah. So let's do a histogram of that. Histogram of residue. Well, this is not normal at all, right? What if we put on more beams there? Like 20, let's try this. No, it doesn't look normal, right? Okay, so heteroscedasticity. So um, this means the residue is gonna have a fan shaped. There is no fan shaped here. There's no fan shaped residue here, so there's none of that. And for the next question, for the last question, the two variables that could include. So if there are two, let's just say I'm interested in everything there and blood cell and white blood thing. So it's gonna be this. So the model, y is still gonna be the duration of stay, and then the two is here. Okay. So right now, the homework is it's over, and just take your time to do your homework. If you don't understand, email me, email other TAs. It's gonna be all right. This is just like a kind of stressful time because it's end of the semester. You are all gonna be fine, okay? And yes, um have a great life. Okay.